Hi, this is Ben from Flexsim. I'm going to demonstrate this model that I built and the diagram that I attached to it. So it's a really simple model. Source, queue, 3 processors. The processors go to a tester. 90% of material through the tester passes and goes to the sink, but 10% fails and goes to the conveyor, where it's rerouted back to this queue and sent through again for rework. Okay, fun little model, but it might be even more fun to be able to visualize that flow with a Sankey diagram. So I did that. So we've got a diagram here that shows the source, the queue with output to the 3 different processors, and each of these links has a relative size that shows the throughput. So there's 60 right now, 51, 24 down here. So you can see this is about half the size of that, and so forth. Now all 3 of the processors feed the tester. 90% from the tester go to the sink and are done. But the other 10% go to the conveyor and go to this rerouted cycle in the Sankey diagram back to the queue. Okay, so this graph is created and updated on the fly as the model's running. It'll build itself with the up-to-date information about what's going on. So it's kind of fun. Another fun thing about this model is you can change it on the fly. So let's say maybe before something can be reworked, has to go through another processor. I don't know what it would be, quality assurance or whatever, but instead of going straight back to the queue, it's got to hit this process and then to the queue. Okay, and maybe we can afford to put another process up here too. Okay, I just added those in. If we reset and run this model and watch the graph start to build itself, speed it up a little. Okay, all the connections are starting to come together. Alright, so you can see now the conveyor has fed that new processor, and the new processor has the loop back. And look, a 4th processor here as well being fed by the queue. So this diagram updated itself on the fly with the latest information from the model's layout, the model's connections, and then is continually updating with the actual throughput numbers at this point in the model run. Okay? So that's the model that we have so far, the kind of the complete version of this proof of concept, having a Sankey diagram. So how did we get here? So this step 1 of this model building experience will show how we got that diagram into Flexsim in the first place. So let's open a brand new Flexsim, and let's go to Google here. I found, in looking for a way to do a Sankey diagram using JavaScript, I found this d3.js library, and that's the important thing here. Once I started looking around there, I found some good examples of Sankey diagrams. Yeah, there we go. So there's this example here, a very complex one about energy usage in the UK. There are also some other examples later on. I thought it would be really useful in Flexsim to be able to show a cycle like we did in that model we just looked at. So I found this example Sankey diagram that has a cycle in it. The chart doesn't actually show up here in Chrome for some reason, but the code is here. It shows up fine in Firefox, by the way. And it shows up fine within Flexsim, which is the important part. So I'm just going to copy this code, and we'll jump over to a brand new model in Flexsim. Okay, so we just want to get that diagram working within Flexsim. So to do that, we create a custom graphical user interface. We'll put an HTML widget out here. We can add the attributes for align right margin, align bottom margin to that widget, and that will stretch the HTML widget to fill the whole size of the GUI. Okay. Now an HTML widget also has a node for some HTML code. Right now you can see it's got heading and paragraph, and that's what you see out here. But we want to show a Sankey diagram instead. So I just paste that code in. The important thing to note here, it's not just going to work right away. See, there's nothing there. Reasonable chart below. That's all we've got. No diagram yet. And the reason is we don't have everything we need. This file is referencing some external JavaScript. So we need to go get those and just include them in this file. Or sorry, in the code of that HTML widget. So if we just copy this, and instead of having an external file be referenced, we'll just put all that code right between these script tags. And then we'll do it again for this external file. Alright, so we've got all the code in there, a nice complete web page, all packaged together as one. Last thing we'll do is I will assign this GUI to the control button. So now I can open it here, and voila, I'm inside of Flexsim. I have a chart that Flexsim's WebKit renderer is building from that web page. It's a great looking chart using the d3.js JavaScript library. And that example from online, we've just pulled that example right into Flexsim. Got a custom GUI with it. So let's look at that example a little closer and try to understand how it's being built just from the JavaScript side of things. Just like any web page, you start off with doc type HTML head, then we've got those two scripts, the external scripts, and there's a lot going on there. Too much to really get into for the purposes of this example. Okay, then you get to the body. There's the reasonable chart below that we saw initially, a chart tag, and then some more script. Okay, this script right here starts to get into the Sankey information, and the really important part that we want to look at is right here. Okay, this is the data that's used to build that chart. In fact, if we added something new here, and something new here, we'll say from 0 to 7, there's a value of 7, Flexsim 7, right? And we open this up, there you go, from 0 to 7, got a value of 7 tuples, it says. Okay, so I just changed this graph by changing that data. Way down at the bottom. Okay, so the question is, how can Flexsim access this and modify it? And we'll look at that in our next